Pre-calc, pre-calc, pre-calc. We're coming down to the wire as far as trig is concerned. And the topic for today, and will be observed after Tuesday's class on the 10th, is the powers of complex numbers. So we learned yesterday on our video, and hopefully got to practice that today, is how to multiply complex numbers in trig form. So suppose we had z1 is some magnitude r1 times cosine theta 1 plus I sine theta 1. So that's a complex number in trig form. And say z2 is r2 cosine of a different angle theta 2 plus I sine of a different angle theta 2. Alright, within each complex number these always are the same, alright, with each other. So when we learned yesterday to multiply z1 times z2, you multiply the magnitudes r1 times r2 and you add the angles. So we get cosine of theta 1 plus theta 2. And we showed why that was true yesterday. And I sine theta 1 plus theta 2. Let me upgrade this to a bracket. Alright, to be mathematically cool. Alright, so here we have that review on how to multiply. So when I take a number to a power, like say I take 3 to the power of 4, it means 3 times itself, times itself, times itself, 4 times. So we're going to do something similar with these complex numbers, but we're going to use the principles of multiplication. So let's say I want to know, say z is r times cosine theta I plus I sine theta. So that's the complex number I'm going to raise to a power. Suppose I raise the power of 2. So when I raise z to the power of 2, I'm going to multiply this times itself. So I'm going to rewrite, there's the number, times itself. That's what it means to square something. And there we go. Fits on there barely. So we recall that when you multiply two complex numbers in trig form, you multiply their magnitudes. So we're going to have r times r, and you add the angles. So I'm going to have cosine of theta plus theta, I sine, and add the magnitude, add the angles. And let me make that into a bracket. Alright, simplifying that, I get z squared is r squared times cosine theta plus theta is 2 theta, and 2 theta with the I sign. Alright, so I want you to observe a pattern. When we squared z, we get r squared cosine 2 theta, I sine of 2 theta. So by hand we'll churn out z cubed, but then we'll switch back and see if we can find a pattern that will always work. Alright, so z cubed is going to be z squared times z. So we already have z squared right there, and we have z right there. So I'm going to multiply these two together, and it will give us z cubed. So z squared, we just found out, was r squared cosine 2 theta plus I sine 2 theta times z, which is r cosine theta I sine theta, Alright, so using rules of multiplication, how do I multiply this complex number times this complex number? Well, I multiply the magnitudes, so I have an r squared times an r. So again, we're trying to cube the original z. So we're going to get r cubed, and we're going to add the angles. So 2 theta plus theta will give me 3 theta. And same for the I sine part. Alright, so I think the pattern is pretty clear now. So what if I was raising z to n, any integer? Then I'm going to get r to the n times cosine of n times theta plus I sine n times theta. And this was so important, this right here, that it was given the name of its discoverer, and it's called de Mauves Theorem. De Mauve is spelled M-D-E-M-O-I-V-R-E. De Mauve. De Mauves Theorem. So we could have thought of that. It's very obvious. So we could have had our name on a theorem. The only thing is he did it in the early 1700s. So we guess we'll give him the credit. All right. So now we're going to use de Mauves theorem to find the power of a complex number. I'll give you the worst case in that the number is going to begin in standard form. So say I have -1 plus square root of 3i. There's 2 forms for any complex number. There is standard form and trig form. We can only use de Mauves theorem when we are in trig form. So I'm going to take this and I want to raise it to the 12th, but before I can do that I have to change it to trig form. So I sketch it. This is the real part. On the real axis it goes back 1 and then it goes up square root of 3. So let me put this -1 below. Alright, so we went back -1 and up square root of 3, and now for complex form we need this number out here. We call it r, and we get it with Pythag. So we're going to do -1 squared and square root of 3 squared, which gives us 1 plus 3, or square root of 4, which gives us 2. So this value, r here, is a 2. So remember, when I write something in trig form, it has a number outside the parentheses, and then it says cosine an angle plus I sine an angle. So that's my little skeleton form, and I've just found 2. It goes out here, and I did it with Pythagorean theorem. Now I need to know the angle from here to here. So the angle is found with inverse tan, and it's always the imaginary part, which is square root of 3, over the real part, and I get negative square root of 3. What angle in this quadrant has this as its tangent? So thinking of the unit circle, I sometimes just try the first one and see if it works. So this one, this is 1/6 pi, 2/6 pi, 3/6 pi. This is 4/6 pi, which is 2 pi over 3. And its coordinates are back a half and up square root of 3 over 2. So if the second divided by the first, does it give us this? It does. So I lucked out. I found it on my first try. So the angle at this point is 2 pi over 3. And 2 pi over 3. So now that I have the number in trig form, let me write it clearly down here. 2 cosine 2 pi over 3 plus I sine 2 pi over 3. We're going to raise that to the 12th, and with the Mauves theorem, it is easy peasy. So the Mauve, notice that you take the magnitude and raise it to the 12th, and then you multiply the angle. 12 times 2 pi over 3, and the same in the I imaginary part. Alright, so let's clean it up. 2 to the 12th is 4096. And 3 goes into 12. 4 times 2 pi is 8. 8 pi. It's going to be the same in the I sine part. And simplifying 8 pi on the unit circle, this is 0. 2 pi, it's also 4 pi, it's also 6 pi, and it's also 8 pi. Because every time we go around the circle, we add another 2 pi radians. So 8 pi, in its simplest form, is just 0 radians. Cosine of 0. Cosine of 0 is 1 times I. Sine of 0 is 0. So this zeroes out. It leaves me a 1. 4096 times 1. So, does it surprise you that negative 1 plus square root of 3 I raised to the 12th equals 4096. Alright, that is quite surprising. So bring your surprised face to class tomorrow and we will do some more of these. Hope that it is clear and that you'll be able to remember how to do it. Till we meet again, goodbye.